Okay, so today we're going to cover trapezoids and kites. Now, trapezoids and kites are not parallelograms. So these two shapes are not going to have the characteristics of the parallelogram. So if you had like a main heading here, and it was probably on that other flow chart, if you had quadrilaterals, it would break off into two branches. You would have your parallelograms here, and then under that would have been the squares, the rectangles, and the rhombuses. But over here, we're actually going to have kites and trapezoids. Okay, so these are quadrilaterals, but they're not parallelograms. So here's our first slide, giving us the definition of what a trapezoid is. So a trapezoid is a quadrilateral, so it's got four sides with exactly one pair of parallel sides. It cannot have two. If it had two pairs, then it would be a parallelogram. So exactly only one pair of parallel sides. Each of the parallel sides is called a base. The non-parallel sides are called legs. Base angles of a trapezoid are two consecutive angles whose common side is a base. So the base angles is going to be where a base and a leg meet. So this would be a base angle, this would be a base angle, and then the same thing in the top. So the bases are actually the top and the bottom of your figure when it's sitting this way. It's going to be the two parallel sides. They may give you a picture with a trapezoid like this. So you can't really say top and bottom, because if you had a trapezoid like this, then the two parallel sides wouldn't be top and bottom. So the base sides are going to be the two sides that are parallel. The leg sides are going to be the sides that are not parallel. Now we're going to talk about a special trapezoid, and this one's going to be an isosceles trapezoid. If the legs of a trapezoid are congruent, the trapezoid is an isosceles trapezoid. So these would be the sides that were congruent. Could it be the bases? Could they be congruent?
Because of parallelogram.
Good. Okay. If they were congruent, if these base sides were congruent, that would make them congruent and parallel, which would make it a parallelogram, and trapezoids are not parallelograms. So it cannot be the base sides that are congruent and parallel. So it's only going to be the legs that are going to be congruent to make it an isosceles trapezoid. Good? All right, anybody still need this slide? Let's go on. All right, here are three more theorems that are dealing with the trapezoids. So the first one states if a trapezoid is isosceles, then each pair of base angles is congruent. And then it says if trapezoid ABC is isosceles, then angle A is congruent to angle D, and angle B is congruent to angle C. So if it's isosceles, then these two angles are going to be congruent, and these two angles. The base angles will be congruent. Theorem 815, if a trapezoid has a pair of congruent base angles, then it's an isosceles trapezoid. So it's like the converse. We're flipping it now. So now we don't have the congruent sides. We've got the congruent base angles, making it an isosceles trapezoid. Theorem 816, if a trapezoid is isosceles, if and only if, remember you could say it both ways. So 816 again, a trapezoid is isosceles if and only if its diagonals are congruent. So here AC would be congruent to BD. So if it's a trapezoid and the diagonals are congruent, then it's isosceles. The diagonals they're referring to are the BD and the AC. And the diagonals go from the point across from it. It's not going to be the consecutive side.
What if the two legs, they're not congruent? Then it can't be isosceles?
Correct.
It has to be both?
It's got, well, what they're saying is if the diagonals are congruent, then it is isosceles and the legs will be congruent.
Oh, okay.
Yes.
They're not bisected or anything, right?
No, they're just congruent. And you can sort of see how it looks like this side right here is definitely smaller than this side. So they are not bisected. But the lengths of them are congruent when it's isosceles. Okay, next. Going to talk now about the mid-segment of a trapezoid. And the mid-segment is the segment whose endpoints are the midpoints of the legs. Now we already saw the mid-segment of a triangle. Now we're going to see the mid-segment of the trapezoid. And again, if I were to add in points, say A here and point B here, then I would say this would be the midpoint of those legs. So the mid-segment connects, the endpoints are going to be the midpoint of the legs. Okay, next is the theorem for the mid-segment. And remember when it was the triangle, it was just half the length of the base. Now we actually have two bases here. So we're actually going to add the two base lengths and then multiply it by a half or divide it by 2. So the mid-segment of a trapezoid is parallel to each base and its length is 1/2 the sum of the lengths of the bases. So you're going to add this base plus this base and then times it by a half or divide by 2. And that will give us the measure of xy. Okay, next are the kites. This is the definition of a kite. So a kite is a quadrilateral with exactly 2 pairs of congruent consecutive sides. So I'm going to talk about the 2 sides that are touching. So like AB and AD are 2 consecutive sides. Notice they are congruent. Then the other pair of consecutive sides would be the BC and the CD. So it's got exactly 2 pairs of congruent consecutive sides. And that forms a kite. Think of a kite as, something that you might have flown in the sky with a long string and takes off. That's a kite. Again, this is not a parallelogram. Now, here goes the theorems for the kites. So the first one states that if a quadrilateral is a kite, then its diagonals are perpendicular. So here is our kite. We've got our 2 consecutive pairs of congruent sides, and then here are diagonals, and they're perpendicular. The second theorem, if a quadrilateral is a kite, then exactly 1 pair of opposite angles are congruent. So here, the 2 congruent angles are B and D. It's not A and C. A and C are not congruent. It's not a parallelogram. If this were a parallelogram, then opposite angles would be congruent. But it's not a parallelogram, so it has exactly 1 pair of opposite angles congruent. Remember the diagonals of the square and the rhombus are also perpendicular. So kites, rhombuses, and squares, all 3 of those have the perpendicular diagonals. The angles that are going to be congruent are going to be the angles that are made from the 2 sides that aren't congruent. So see how it goes from this with the 1 tick mark to the 2? So it's always going to be the angle made with the non-consecutive sides, or the non-congruent sides. Okay, our first example, it wants us to find the measure of angle A. Now, remember, this is not a parallelogram, so opposite angles are not congruent. So we can't automatically say that this angle is 100. What do we know that we could use to find the measure of angle A?
There's exactly one pair of parallel sides.
Okay, so we have a pair of parallel sides. So we have AB parallel to CD. What else? Well, what can we use for that to find the measure of angle A?
You can tell that it's an isosceles trapezoid because of the congruent.
Okay. All right, so we know that these two angles are going to be congruent because we have the two congruent legs. Okay, what else could we do? So we also know that these base angles up here are congruent too, right?
But only the base angles are always going to be parallel, right?
The base angle, the base side, the sides, yes, will be parallel.
The legs will never be parallel.
No, they will not. Okay, so how can we find A? So we know that this one's 100. So this is one way we can go about this. What else can we do?
Well, like, since you know that a quadrilateral always has an internal angle, the sum of 360. So you can do 360 minus 200, and then divide that by 2.
Beautiful. Okay, that's one way. And find out that they're each 80. Okay, we can also go back to stuff we learned before Christmas. And if we know we have a pair of parallel sides here, we also have a transversal, and we know that these two angles are same side interior. And same side interior angles are supplements. So if I knew one was 100, I could just do 180 minus the 100 and got 80 also. So there's more than one way to go about this. But what he did, that was beautiful. He knew that the interior angles of a quadrilateral are 360. He knew that the two base angles, because it was an isosceles trapezoid, were congruent. So we already had these two, which were 200. Subtract the 200 from 360, get 160 divided by 2 and get 80. Isabella.
Couldn't you also make the angle next to 100, you would figure out that it equals 180 and then make that 80 and then kind of alternate interior angles to the bottom?
Well, we didn't have a diagonal there. We could have just done the same side interior.
I mean, like, that would be the transversal, the line 80.
Oh, you mean outside?
Yeah.
Like over here?
Yeah.
Or over here? Yes, you could. Yes. Yes, if you were to extend the lines of the figure and you knew that exterior angle was 100, you could have. All right. Everybody good on example 1, 2? Okay, so we still have a trapezoid here. It's actually an isosceles trapezoid. We have the two legs that are congruent. So what can we do to find the measure of angle F up here? So again, we got our parallel sides. We've got our congruent base angle, our base sides. So what will that tell me about angle E? How much is it going to be? 49. So it's congruent. So what do I know about angles F and E? What are they?
Same side interior
Good, which is what?
equals 180.
Good. So I'll do 180 minus 49 and find out that angle F is 131 degrees. I could have also added 49 and 49, got 98, subtracted that from 360, and then divided that by 2. So that would have been another way you could have gone about it. Yes. Example 3. Now it looks a little bit more complicated. We've got some diagonals in here. What do we know about the diagonals of an isosceles trapezoid? They're congruent. Good. So we know KB is 21.9. Just this little piece right here, 21.9. And then I also know that MF, the whole thing, is the 32.7. It wants me to find the measure of FB. What could I do here if I know these diagonals are congruent? Yes. Perfect. I'm going to take the 32.7, the length of the whole diagonal, and subtract out this little piece to get the other little piece. So once I do that, I get 10.8. So FB equals 10.8. Example 4. Now we have kite A, B, C, D. They're giving us the measure of angle DAB, which is right here, and it's 54 degrees. It's also giving us the measure of CDF, this one right here, which is 52 degrees. So in our kite, we know that we have two pairs of consecutive congruent angles, or sides, sorry. So I can add in my little congruency marks here. I also know that I have two congruent angles. So this angle, let's see, let's do this in green. This one is congruent to this one. Now, we want to find the measure of BCD. So they're asking us to find this one right here. What do you think we could do? What if we look at, you want me to give you a hint, or you guys want to think about it? See if anybody can figure out what we're going to do. Think of this as they've now split it up into smaller triangles. Okay? I actually have a bunch of them. I could have the 4 little individual ones. I could put 2 together and make a bigger one. Now the 52, this angle right here, is just for this piece right here. It's not the whole angle. Michael?
You can, like, you know that they are perpendicular, so that adds 90-degree angles.
Okay.
On all of the triangles. And then you can do, add the 90 to 52 and you'll get the, and subtract the 180 and then you'll get that side. And then do the same, oh wait.
Okay. What if I look at it like this? This triangle right here. What kind of triangle is that? Isosceles. And I know the base angle is 52. So then this is going to tell me this other angle over here is 52. So then I'll add 52 plus 52, or times it by 2, and get 104. And then I'm going to subtract that from 180, because the 3 angles of a triangle add up to be 180. Subtract those, and I find out the angle that I was looking for, the one up here, is 76 degrees. Okay, so again, label everything you can about the figure. Okay, it didn't have those congruent sides in the picture or in the given information, but if you know by definition that a kite has a pair of consecutive sides that are congruent, you need to throw in those congruency marks, because then you can clearly see the isosceles triangles if that's what it creates. So label everything you know, because you never know what piece of information is going to pay off to help you out. Everybody good on example 4? Yes.
Which chapter was it? Did we learn about the isosceles triangles?
I'm not sure. I'd have to go back and look. I'm sorry? 4? Okay, I'll double check it after we finish the slides. We're almost done with the slides, and then I'll look it up for you. Okay, next one. Example 5. Another kite. It says Lucy is framing a kite with wooden dowels. She uses 2 dowels that measure 18 centimeters, 1 dowel that measures 30, and 2 dowels that measure 27. To complete the kite, she needs a dowel to place along KL. So she needs a dowel to put right here. And she needs, to complete the kite, she needs a dowel to place along KL. She has a dowel that's 36 centimeters long. About how much wood will she have left after cutting the last dowel? So here, we're gonna, label our picture. We've already got numbers here, so we can clearly see that this one is congruent to this one, and this one. We also know that these dowels, or these diagonals, are perpendicular. So I actually have 4 right angles here. Now, we also know that across the whole length here, or the whole width of this kite, is 30. So that tells me that this is 15 and this is 15. I need to figure out how big this is and how big this is. And then I'm going to subtract that. She's using the dowel that's 36 centimeters, but we need to find out how much wood she's going to have left. She's not going to use the whole 36-inch piece of, or centimeter piece of wood. So what do you notice we could do to find some of these lengths? Manuel?
The Pythagorean theorem.
Good. We're going to do 2 Pythagorean theorems. We're going to do it for this upper triangle here, and then we can do it for right here. We're looking for 2 legs. So here, we're going to do a squared plus b squared equals c squared. So we could say that the missing one is a squared. We have the 15 squared, and then 18 squared. So I need to do Pythagorean theorem here. So I need to square 15 and square 18. 18 squared is 324. 15 squared is 225. I'm going to subtract. And once I subtract 324 and 225, I get 99. Now, I don't think we're going to use a calculator for this, so we'll probably approximate this. So I know this is really about, I could break down this radical because it's really going to become square root of 99. So I could do 9 times 11 and get 3 radical 11. And 11 is close to the perfect square. Could say it's close to 3. Let's see. So you got the perfect squares, 9 and 16. So this would be 3 squared and 4 squared. So it's closer to the 9. So I'm going to say that the square root of 11 is about 3.2. Times it by 3. So that little piece is going to be 3.2 times 3, and it's about 9.6. Then for the other one, again, I'm going to do a squared plus 15 squared equals 27 squared. 225 for the 15 again. 27 times 27 is 729. Subtract the 225. A squared equals 504. So A is equal to 504 square rooted. I could start factoring this. And I could do like 2 times, actually I'll do 4. 504 times divided by 4 is 126. So let's do this as 4 times 126. Now I could keep breaking this down, but because I'm approximating it, I know that the 2 perfect squares 126 is in between, is 11 and 12, and it's closer to the 11. So again, I'm going to approximate this to about 11.2. Square root of 4 is 2. So then I'll multiply 11.2 times 2, and I get 22.4. And then now I'm going to add those two, 9.6. So now the 9.6 was here, and the 22.4 was here. Yes.
Why did you multiply by like 2 and 3?
Because the square root of 4 was 2, and the square root of 9 was 3. And so here I'm going to add 22.4 plus 9.6, and I'm going to get 32. So the length of the piece I need for my kite is 32 centimeters long. I'm cutting that from a 36 centimeter piece of wood, so that would leave me with 4 centimeters left. Okay, keep in mind that this is probably going to be an SAT question where they're going to be combining your skills and making you apply your critical thinking. So this could be a potential good SAT question. Yes?
Couldn't we just do the Pythagorean theorem with 18 and 27?
18 and 27. No, because I need a right triangle. So you can only use Pythagorean theorem when it's a right triangle. So those wouldn't necessarily be the legs of a right triangle. Make sense? All right.